Alright, good morning. Welcome to Mr. Lute Science Class 101. Now, before we are done with our mixture, so we're moving on to our next topic, which is force or force and pressure. Now, in this lesson, we will only be looking at force. We will not tackle pressure. And even with the force, we will not do all the force. We'll just do up to a certain point. Now, first question, what is a force? Now, we say a force is simply or basically it is a push or a pull of an object. So a force is a push or a pull of an object. And mathematically, we say that force is the product of mass and acceleration. So force is a push or a pull. Or we can say force is equals to mass times acceleration. Now, because force is a quantity, it has a unit, and then the SI unit of force is Newton, or capital N. Now, let's see. Now, because it's named, the unit is Newton because it was named after Sir Isaac Newton. He discovered force, so the unit was named after him. Now, force has different ways of affecting bodies. Because if I should hit you, it means I'm hitting you with the force. And when I hit you with the force, it means it will have a certain reaction on you. Now, let's see. Now, if you have a body which is stationary, that is a body which is not moving, and you apply a force, it will cause that stationary body to move. So one effect is that it causes stationary bodies to move. Now another effect is the opposite of the first one. Now instead of making stationary bodies move, it will rather make moving objects to stop. So if the card is rolling, I just use a little force to stop it. So the second one is it makes moving objects stop. Now the third one is it causes a change in direction of a body. It causes a change in direction of a body. So for example, when you are playing football and then they give you a pass and then you want to give the pass back to the person, even though the ball is coming towards you, you sometimes hit it and then the pass will go sideways to a different person, or it will miss who you want to give it to. So that is, a force can cause a change in direction of a body, or a ball is thrown at you, then you hit it into a different direction, like when we are playing stay. Now the fourth effect is it causes a change in speed of a moving object, either a decrease or an increase in the speed. So for example, if this T-roll card is rolling, and I start to hit it hard, you see that it moves faster. So it causes a change in speed, that's an increase or a decrease. And then the final effect of a force is it causes a change in shape of an object. So I have with me a piece of paper that I'm going to, you see it's flat. So I'm going to now apply force, as I'm going to squeeze it. And you see that the shape has changed. It's no longer flat. Now it is, I don't even know how to mention the shape, but let me try and squeeze it into something spherical. That is, let me make it a bit round so that it will move from flat to round. So that's the final one. Now we'll be looking at, now that we know the effects of forces, now let's look at the types of forces. Now we have different types of force. Some of you will be saying spiritual force, but spiritual force is not a type of force in science. Now the different types of forces that we'll be looking at, we'll not delve deep into them. We'll just look at their definitions and then maybe one or two applications of them. Now the first force we look at is what we call gravitational force, or force of gravity. Now gravitational force is simply a force that pulls object towards the center of the earth. A force that pulls object towards the center of the earth. Now this force of gravity was actually discovered by Sir Isaac Newton. history has it that he was sitting under an apple tree and he saw an apple fall from the tree, and he became fascinated by how come the apple, when it got ripe, it didn't stay up there, and then it started to come down. So he did a little research and he came out with what we call gravitational force. Now, gravitational force or force of gravity is not constant. On the earth, it has a value. On the moon, it has a value. So if you are a fan of watching space movies, you see that sometimes when they go to space, they float, because they said in space, gravity is 0. So everything floats in space. And on the moon, gravity is 9.6. So on the moon, you can't walk like the way we walk on Earth. They are walking, it's more like bouncing. They hop on the moon. That is it. Now, the second force we look at is weight. Yes, don't be confused that by weight. Weight is different from mass. When you go to the hospital, what they check is your mass. That is not your weight. Now, weight is simply the product of mass and acceleration due to gravity. So weight is simply mass times gravity. That is your weight. So you can, when you go to the hospital, what they check is not your weight. It is rather your mass. Even babies, when they go, they say they are going for weighing. They are going to check their mass, not their weight. Now, the third force we look at is what we call tensional force. Now, tensional force is a force that pulls objects apart or causes objects to stretch or put them in tension. So, for example, here, if I have a rubber band and I pull it apart this way, it is tensional force that I'm using to stretch the rubber band. Now, the opposite of tensional force is compressional force. Now, instead of tensional force pulling things apart, compressional force pushes things together. It pushes them together. So when you stretch a rubber band and you use tension to pull, when you leave it, it is compression that will pull it backwards to its original position. Now, compression can pull it back, or it can even push it very close. So if, let's say, you want to destroy a can, so you pick the can, when you are squeezing it, you are compressing it. That's why the can will deform and become that shape that you would have in your hands. Now, the fifth one we look at is centripetal or centripetal force. Now, centripetal force is basically a force that pulls objects towards the center in a circular path. It pulls object towards the center in a circular path. So if you are running in a circle, the force that pulls you towards the center of the circle is what we call centripetal force. And this is mostly experienced when you are sitting in a car and then you are going around a roundabout. In your mind, you feel that the car would skid off the road, but centripetal force will rather pull the car towards it so that it doesn't go sideways and then veer off and hit something. Now, the opposite of centripetal is centrifugal. Now, unlike centripetal, centrifugal rather pulls objects away from the center in a circular path. So while centripetal is pulling you inside, centrifugal is pushing you away. Now, centrifugal force has a part to play. Now, when you are spinning an object in a circular path, it is centrifugal force that prevents the thing from falling down. So I'm going to demonstrate with my rubber band. I have to tell you too. Then I'll use it to tie my marker here. Now, as I spin it around, the marker is supposed to fall in, but centrifugal force is keeping it from coming towards the center. It's making it stay out and giving me my circular path. All right. Now, the next force we look at is what we call electrostatic force. Now, electrostatic force is the force that exists between static charges on stationary objects. It's a force that exists static charges on a stationary object. Now, sometimes there's this thing that we feel when you move close to a television and then you pass your hand in front of the television, it feels like the hairs on your skin are being pulled towards the screen, or they stand upright. It's because of electrostatic charge now on the screen of the telly. That's why it feels like it is pulling the hairs on your body. Now, to demonstrate this electrostatic force, I have here a ball crystal pen, and then my hair, which is going to be my rubbing medium. So I'm going to rub my pen in my hair vigorously, severally, severely, any way you want to do it. But just make sure that you don't hurt yourself. And please, when you are doing this, make sure your hair is dry. This one, I've taken my bath, so you might not get the results that I want. So in here, I have pieces of papers on this sheet. So I'm rubbing my pen, and I'll use the pen to pick the sheets of papers. You can see. Okay. So that is electrostatic force. So any static object has charges, but it's only left to how to activate those charges. And once you activate the charge, you see that it has electrostatic force. Then the last two that will be done for today is magnetic force. And magnetic force is simply the force of attraction that exists between a magnet and magnetic substances. If you tried this thing before, when you open your fridge door and you close it, even though you don't let the door touch the fridge, that small gap that you leave, instead the fridge is able to pull the door towards it. That force that the fridge uses to pull the door for it to shut is what we term as magnetic force. And you can also have it when you pick a magnet and then you try to bring it close to a coin or any magnetic substance, any substance that has iron inside. It just picks it up easily because of the magnetic force. Now, the last force that we'll look at, that will bring today's lesson to an end, is what we call frictional force. Now, frictional force is basically a force that opposes relative motion between two surfaces in contact. It's a force that opposes relative motion between two surfaces in contact. So if you have two surfaces, let's say my two palms, and I bring it together, I'm supposed to be able to slide my palms easily on each other. But you see that sometimes when you are trying to slide, it's a little bit difficult. Or when you have an object on the floor and then you want to drag it, it's like something is holding onto it, something is preventing it from moving. That force that prevents it from moving is what we term as frictional force. Now,